All right, so slides are working. Awesome. So I'm Rahul. I'm a product manager at Maluuba, and today I'm going to talk to you about how we at Maluuba are building literate machines. So I'll talk about talk a lot about what that means. So there's a lot of work that's going on in deep learning, and as we've seen today, from autonomous cars to the stuff Amazon is doing with Alexa, and it's all really, really exciting. But what we focus on at Maluuba is using deep learning to really understand language. What that means is, we're teaching machines the ability to think and to reason and communicate in the context of language. Some of the work we do in industry also works very well with our partners in academia. And we think that's actually really important for industry and academia to work together, especially on the research side, to really push AI and deep learning forward. So we work with Professor Bengio in Montreal, and also Richard Sutton, who's really well known in reinforcement learning. So both of these professors actually work really closely with industry just to push this deep learning agenda forward. Actually, I should have put this first. I'm still getting used to this. But we recently got acquired by Microsoft. And this is one of my favorite articles that was written about us. It says that we're DeepMind with a commercial tilt for Microsoft. What that means is, as excited as we are about pushing deep learning forward and pushing language forward, it's actually really, really important to sort of infuse that technology that we're building today into enterprise products. I think that's one of the main reasons why Microsoft actually ended up acquiring us, because we focus on research, but we also try to infuse it into applications as much as we can. So this was our sort of claims to fame. This is what really put us on the map. This is what really got people talking about Maluuba. And it was almost a year ago, I think it was June 8th, where we actually put out this system that could reason about text, or read text just the way human beings do, and actually reason about it and answer questions in a very natural way. So I have a demo to show you. Hopefully it works. Oops.
We perform billions of search queries a day. They range from simple questions such as, how old is Barack Obama, to a bit more complicated question like, what are Trump's thoughts on immigration, which seem to change from day to day. While search engines are getting better at providing direct answers, they still fail to keep up with new and relevant information. Google tells me Bill Gates is worth $78.6 billion, but according to a CNN article from last week, he's now worth 90. With volumes of written text being produced every second, how do we make sure that we have the most recent and relevant information available to us? Maluuba is tackling this problem by building AI systems that can read and comprehend text in real time. On screen, I have an article about President Obama dining with Anthony Bourdain. I have no idea who Anthony Bourdain is, and I really want to know what restaurant they ate at. Instead of me reading the entire article, I'm going to ask Maluuba to read it and answer these questions for me. So for the first question, it tells me that Bourdain is a celebrity chef. Let's see if we can answer the second question as well. So Maluuba comes back with a restaurant name that I'm not going to pronounce, but it can be found in the article here. Let's take a look at a couple more examples. Here, the title of the article says that US makes more payments to Iran. So my first question is, how is the money transferred? Because that's a lot of money. It looks like it was flown in on an airplane. My next question is, why did the US pay Iran? Let's see if the answer exists in the text. Here, Maluuba tells me it's because of a long-standing legal claim. The extension is powered by our deep learning algorithms that can reason about problems like a human does. Let's take a look at one last article. This is a pretty long article, and I really just want to know a couple of things. Where is Anjem Choudhury now, and how long is his sentence? Current Q&A systems rely on neatly organized structured data stored in databases to answer questions, which often contain outdated answers. Maluuba's system, however, can understand unstructured text, making it possible to provide most up-to-date answers in real time. Here, the system tells me that he has been sentenced to prison for 5 years and 6 months. To wrap up, Maluuba is building AI systems that can provide direct answers by reasoning over unstructured text in real time.
So what's really exciting about this demo is that we didn't actually train our models on any of these articles, right? Like, we trained it on general data, and it was able to really read the text with the question I'm asking in mind, and then reason about it in real time. So we build a Chrome extension. Moving forward, we might build like an Edge extension because of Microsoft, but we built a Chrome extension that was powered by neural nets in the background. And as I went to a page, I would just ask any question I had. It would read it in real time and then come back with the answer. I mean, obviously, like, it didn't work all of the time, and I don't want to waste time showing that here, but when it does work, it's actually really, really incredible. Because what we have built, or what we are trying to build, is these general capabilities. So we're not going for, a medical expert or a legal expert. What we're really trying to build is, what are the human skills that we have, and can we sort of build that into machines? So obviously, like we've all heard today, AI is a big thing, deep learning is a big thing. All the prominent players in the industry have said this is like their highest priority. But what are like the core applications of artificial intelligence? So the way I break it down is, you have speech recognition, object recognition, and machine translation as perception, and then you have sort of NLU, reinforcement learning, and reasoning and memory as intelligence. So over the last couple of years, we have done a lot of work in the top three things. We have reached human-level parity on speech recognition and machine translation, and I think we've surpassed it for object recognition and image detection. But we really haven't done a lot of work on natural language understanding, and that's something that really what Maluuba is focusing on. So I'm sure you guys saw this from a couple of months ago, that Microsoft researchers reached speech recognition at a human level. But with this is really exciting because if you see from 2010 to about right now, we're reaching this human parity. And a lot of that is happening because of the advancements in deep learning. So before 2008, 2009, none of this was really possible. We were kind of we plateaued at like the 65%, but now we're seeing a lot of advancements. So why language? Why does Maluuba really care about language? And that's because we think that's the only thing that differentiates us from the animal species, or it's one of the main things that differentiates us from animal species. We sort of work on a very simple premise that's actually very, very hard to accomplish. It's that if you took the basic human traits like reasoning, adaptation, jumping from one state to another, things that humans are really, really good at, and sort of combine that with things machines are really, really good at, such as like ingesting a lot of data and parsing through a lot of data really, really quickly that humans can't do. And if you combine those two things, then you've unlocked like this, this thing where the applications that you could build with this are limitless. So that's basically our vision statement: to teach machines to build literate machines, teach them to read, to teach them to write, and to teach them to speak. So we see a lot of, NLU has been applied a lot in consumer space today, and we've seen that throughout the day, starting with Alexa this morning. So I won't waste a lot of time on that, but I do really want to focus on the enterprise, and that's something we care about a lot. So the survey says that 62% of enterprises will have deep learning models powering their applications by 2018. I think we'll reach that this year, and by next year it'll be more than 62%. So 5 years ago, if I asked you guys to name an application or product or service that you use deep learning or AI, it would have been really hard to come up with one. But in 5 years from now, if I ask you the same question, it will actually be really hard for you to come up with a product or application that actually doesn't use deep learning or doesn't use AI. And that's going to be really true in the enterprise space. So I just want to get this fact right. Yeah. So about 15% of workers' time today is wasted, looking up information. So if you think about what you do at work, you go through your emails and you're looking for these emails, and it takes a lot of time. Or in a customer service setting, like, you want to talk to an AT&T rep, you're either waiting on the phone for 45 minutes or you're talking to an online agent, and all they're really doing is having the exact same conversation with you and millions of other customers over and over again, which is really, really frustrating because we think that that's a waste of human time and human resources. We're really good at being creative, reasoning against things, and that's what we should be focusing our time on, and not these repetitive tasks. So if we think that if you can take these repetitive, monotonous tasks that we do every day and sort of offload those to machines, then we can free up our time to think more creatively and build things that make a difference. So these are really simple examples. You can talk to a customer service agent because all they're really doing most of the time is retrieving information for you or completing a transaction. And it's the same type of information retrieval and transaction over and over again, and it's really, really easy to automate that. So obviously these are like the low-hanging fruits that the customer, that the market is going after. Yeah. So there are a lot of, we talk about what's possible, but there are also a lot of limitations in AI. Earlier today, I think it was Malaika who was talking about reality versus hype. And the hype in AI is incredible. People expect AI to be able to do things that it really can't do. So like 2010, 2011, when Siri came out, it was really cool that I could take out my phone and start talking to it, and it understood what I was trying to say. But I think there was all this hype that, wow, I could have a great conversation, an in-depth conversation with AI, but that's not really true. I was in Montreal last week. I was at an AI event, and there are all these startups that say, they're an AI company. And some of them are, some of them have fundamental technologies, some core technologies that can be applied to build products. But it just becomes really easy to raise money if you call yourself an AI company, which is really bad from a consumer perspective, because then you expect all these products to be able to do these incredible things, and then when it doesn't happen, you're really, really disappointed. So we believe that AI companies are sort of bounded by this graph here, where users expect something, but the capabilities or the abilities of the AI are extremely limited. But the reality is that a lot of these AI programs, including Siri, they're just commands that we can say into our phone. Sure, there's some deep learning to understand what we are saying, but at the end of the day, it's just intent recognition, and based on that, they execute. And they're trained on a lot of data. So something that was incredible that happened in 2011 that that was actually a big deal for human beings to accomplish in the context of machine learning or machine intelligence is IBM Watson. So IBM Watson actually competed in the game of Jeopardy and actually did incredibly well. But I was like, oh my God, AI is so smart today. I can do a whole bunch of things. But the reality is when you take Watson and apply it to something else, it actually falls flat on its face. So it's actually a very narrow, really well defined, really well done, but it's extremely narrow, and it actually doesn't scale to any other domain. So yeah, these 3 points are pretty self-explanatory. Deep learning models today require a huge influx of data. They lack fundamental reasoning or transfer learning capabilities. What that means is when you train something on one domain, it only works on one domain, but it doesn't work on anything else. As human beings, we don't operate that way. We learn in a very general way and not in a domain-specific way. So yeah, I'll just skip through these slides because it just talks about how everything previously was rule-based. With machine learning, we were able to automate a whole bunch of things, but with deep learning, hopefully we can start to learn a lot of these features, so we don't actually have to manually engineer these features. We can get deep learning models to actually learn a lot of these features. So this is another demo that we're working on at the moment, and this is here. I actually uploaded just a chapter from Harry Potter. And I started asking it some questions. So what's a little bit different about this is I could actually ask contextual questions. So for example, what fell out of the sky? A motorcycle fell out. And when I asked who was riding it, it actually understood I was talking about the motorcycle. And this was all, this was not hand programmed, this was not crafted. It's just, we trained it on enough data that it actually learned all these things. What happens next is actually even better, because I go from asking about Harry Potter to a medical document. So this, again, the model has never seen any of this information. I start asking it questions, and it starts retrieving answers for me that, it would take me a few minutes to read through this medical jargon, or I can actually just ask it. So again, we haven't really built, a Harry Potter expert or a medical expert. We've actually given the machines like the basic fundamental human skills to read. So for example, a 14-year-old child, if I ask them, what is the 17D vaccine, they wouldn't know, but whereas a doctor would. But if I asked them, what is the 17D vaccine, and I gave them a document to read, they would actually be able to come back and provide an answer, which we think is really incredible if we can impart those skills into machines. So just a little bit about where we came from. About last year, around this time last year, we started looking at some of these data sets that are available for machine reading comprehension. We perform, it's a little bit outdated, because at that time we actually beat state-of-the-art results that were really Google, DeepMind, Facebook, Microsoft, and IBM. They were the leaders in it. So it was really cool for a startup to come in and compete on that level. But what that also means is that the startups today have the ability to do this. You don't have to be a behemoth to, push AI, push deep learning forward. And what's really funny is Microsoft actually has the state-of-the-art results on all of these data sets today. So once we actually taught machines how to read and how to come back and provide answers, we started thinking about, well, what's next? Sure, machines can read, and there's still work to be done, but we want to think about what's next. So what's next is, can you teach a machine to actually actively go out and seek information? So not just that I'm going to ask a question, it's going to come back. Can it just go out and start looking for information? So we started with this little toy task, and we applied it to Hangman. We applied it to a couple of other games, where it would just ask simple questions. It's the next letter A. It's the next letter B. And then the machine would answer yes or no, and then it would just try to complete the puzzle as quickly as possible. Once we did these little toy tasks, we started thinking about, well, how do you generate questions? How do you actually get machines to ask intelligent questions and not just these simple, is it A or is it B? So we actually flipped the equation. So now instead of taking these data sets that have document and question and answer pairs and getting them to answer questions, we actually fed it documents and answers and asked the machines to come up with questions And this actually helps us in multiple ways. One, we can use our information-seeking models coupled with question generation. So now we can build machines that can go out and ask intelligent questions to Google or Bing, retrieve information, read it, reason against it, and build this knowledge about the world. But also we actually started working on machine writing. So machine writing is an unsolved problem. Everyone else knows is that natural language generation, but machine writing is just another way of saying it. And generating questions has turned out easier than actually providing answers. But what would be really, really cool is instead of just extracting answers, like I've shown previously, what if you could get machines to actually generate them? So can it read 4 or 5 different documents, think about what it's reading, and then actually write an answer that makes the most sense? Because if you think about it, that's what human beings do. So I have a quick demo.
While there's been a lot of work in machine reading comprehension to develop models that can answer questions, we have been exploring another approach, teaching machines to ask informative questions. It has been demonstrated that learning to ask questions may improve the ability to answer them. The ability to ask questions is also important for learning and seeking new knowledge. To demonstrate our system's questioning capabilities, we'll give it some text and have it formulate questions about what it has just read. Let's start with this article on Tesla. I'll highlight the first 2 paragraphs and see what questions the model comes up with. In this case, the system reads the 2 paragraphs in real time and generates around 7 intelligent questions. Our neural model first encodes document and answer candidates, then outputs question words sequentially using a decoder conditioned on both. The question here is particularly interesting, as it thinks that location can be assumed from the name of the hotel, Hotel New Yorker. Next, let's try our model on a Wikipedia article. When we trained our model, we used reinforcement learning to maximize several rewards, which include a language-based score for fluency and the performance of a pre-trained question answering system on generated questions. Finally, let's look at a story on Microsoft's blog about tackling water scarcity. I will highlight these paragraphs here and see what questions the model asks of them. The model generates questions that allow us to learn all the facts, such as where the multi-year drought took place, and learn information about Karen Chalk, such as where does she live, and what program was she trying to create to tackle global problems. We hope that this work will foster intelligent systems that can both ask and answer questions to increase their understanding of the world.
So again, these systems aren't built to only generate questions on Wikipedia or a blog post or a Microsoft blog. They're very general, so you can plug in any website, any data that you have, and generate questions. Eventually, we would like machines to generate them automatically, so you don't have to actually highlight the text, but it can intelligently ask questions and use a separate model to actually generate answers. And this is great for like an education setting or like frequently asked questions or anything related to the enterprise. So that was the machine reading comprehension work that we do. I quickly want to talk about conversational interfaces. A lot of people have talked about that today, so I'll skim through this relatively quickly. But there's actually still a lot of work that needs to be done in conversational interfaces. Machines still lack the fundamental intelligence that human beings have. So for example, I'll give you an example. We're actually working with an insurance company, and one of the use cases they have is, someone will come in and say, my husband just passed away, how do I claim their insurance? You can't get a chatbot to say, cool, I can help you with that. No, that's not, the machine at that point isn't cognizant of it doesn't understand the context. So you can't pre-program these different use cases. It will take a really long time to pre-program all of them. So how do you actually teach machines to really understand the context of what's being said and respond in an appropriate way? I've been using Siri for 6 years now, and it still really doesn't know anything about me. The questions I asked like 3 years ago, it still comes back with the same response. So how do you actually get these systems to become more intelligent like human beings and get to know you better? And what I mean by that is, I love this graph because on one hand you have contextual understanding, on the other hand you have value of relationships. And chatbots today or personal assistants today are a little bit better than the rude guy you see on the bus stop. So you might ask them some question, the guy on the bus stop some questions. He might respond, he may not respond. He definitely won't remember you. He doesn't really care much about you. And that's really where the systems are today. Where we want to go is get to the friend level. We don't want to get to the spouse level. There are movies about it. You can watch them, but that's not what we're interested in. But what we are really interested in, can you build like a companion that knows you as well as your friend does, that actually remembers things about you, so you're not repeating yourself over and over again. And that's a really long road to go, like really long path that we need to go through. But that is really where we should be going. So I just want to jump back into enterprise applications really quickly because that's what I really care about. So back to machine reading comprehension, there are so many different use cases. So for example, we're working with an automotive company where they have this 400-page manual and no one really reads them. But when you're really stuck on the side of the road and really need to know how to change your tire, you don't really want to be flipping through this manual. So what if you could ask a question in natural language, use our technology to read this 400-page manual, which would come back with an answer and tell you exactly what you need to do to get moving. we just joined Microsoft recently, and they have so many different policies about vacation days, about health plan, and I don't remember all of them. What I really want to know is how many vacation days do I have, or how do I claim insurance for my health plan, without reading through hundreds of documents. And machine reading comprehension can really get us there faster. And now I'm not wasting my time reading these documents. I can focus more on my work and less on retrieving information. So this is one of my favorite use cases, and I wish we could build this today. We all spend so much of our time reading through emails, retrieving information from emails from years ago. So here, I was in Redmond a few months ago, and I really just wanted to know what hotel I should be staying at. Instead of reading through hundreds of emails and finding that exact email, I should just be able to ask a question in natural language, and it should come back with an answer. So this is a semi-structured query where I ask about a specific email from a specific person. But in the next example, I don't do that. I just ask any random question. It should be able to read through it. For example, I don't have an executive assistant, but if I did, and I asked them a question to go through my emails and find the answer for me, it should be able to do that. And once you do all of this, again, you give back human beings the time that they need to be creative, to work on really, really hard problems, and not waste their time on doing this repetitive, monotonous information retrieval tasks that machines could be extremely good at. So what's next? Machines still lack fundamental common sense reasoning. So there's a thing called vinaigrette challenge. When I say I poured water from the bottle until it was full, what was full? For us, it's really simple. That the glass was full. But for a machine, this is really, really hard because the intelligence is not grounded to reality. And that's something we focus on from a research perspective. Another thing that we, throughout my talk today, I've talked about building these general systems, so not domain specific. It's great if you find product market fit for a specific domain and build a great solution. That's fantastic. But if you really want to, from a research perspective, we really focus on building these general systems. And these systems need to be able to transfer knowledge from a domain where there's a lot of information available to a domain where there isn't a lot of information available. So how do you transfer that learning from one domain to another? And finally, multimodal. So when we perceive the world around us, it's not just text. There's actually images involved as well. So how do you get machines to look at and retrieve information both from text and images and combine it together to become even more intelligent? Oops. So I think that's all of my talk. I just want to put this out. We're hiring a lot in Montreal. It's the epicenter of deep learning. We're closely advised by Yoshua Bengio, who is still in Montreal. It's a great environment. So if you were looking for a job, please come talk to me. I just really want to quickly talk about this slide. There's a lot that still needs to be done to move towards artificial general intelligence. Today we are only focusing on 2 or 3 of these things. And we're still early on those 2 or 3 things. So we still think there's a lot of work that needs to be done to build truly literate machines, to give machines the capabilities and the abilities that human beings have. That's it. So I have about 90 seconds left if you have any questions. Yeah.
So, can you touch upon how you use deep learning for the text comprehension problem, right? Was it more germane to convert the text into knowledge graph sort of a format and then do search?
No, so we actually don't generate knowledge graphs at all. We actually train our models on question, answer, and document tuples. So we feed it during our training stage. We'll give it a document, we'll give it a question, and we'll also show it what the answer should look like. So if you train on enough data, once you go to your validation stage, we can actually just give it question and the document, and it's actually able to retrieve the answer for you without actually building with a knowledge graph.
Then you need to generate a lot of questions to train the network.
So there are actually a lot of data sets available out there. MS Marco is one of them. We actually released one called NewsQA. Google had one on CNN articles. It was about 100,000 question-answer pairs. So there are a lot of data sets available out there. Yeah.
So it looks like it does pretty well on small text corpuses.
Yeah.
I was more interested in like a much larger text corpus in terms of both runtime and then if there's multiple valid answers within the same corpus, how does it?
Yeah, that's a great question. So in the question generation, so first part, yes, it only works on small text today. Our goal is to expand it to multiple documents. But in terms of your second question about multiple answers, it's on the question generation stage. We actually generate a whole bunch of different questions, and then we use reinforcement learning to figure out what's the best question. So I think if we extrapolate from that to answer generation, you might be able to do the same thing where you generate a whole bunch of different answers, and then you pick the best one using reinforcement learning. Obviously, there's human beings involved in the training stage to pick the best answer, but our hope is that over time, with enough data, machines can actually learn what the best answer should be. Yeah.
So if the Leningrad challenge was
Mm-hmm.
goal, are we going to get there quantitatively with more data and bigger machines, or is there something qualitative that we have to do?
I think there's something qualitative. That's my personal opinion. I don't think data on its own is going to be enough to teach machines common sense reasoning.
So we should not extrapolate from where we are?
No, not at all. I think we'll need not just text, but actual real-life experience to get common sense reasoning. So you might have to learn from interacting with the world, maybe like watching movies and videos and learning more about the world, about how human beings experience it, and not just from text. Yeah.
What's the gap at the moment between training for doing question and answer detection on domain-specific data sets, and very generalized data sets that you guys are working on? Is there still a big gap?
Yeah, there's still a big gap, and that's why I talk about transfer learning. There's a big gap between the data sets we use today versus applying it to anything general. Because there are a lot of domains that are very specific domains for which a lot of data isn't available, and our algorithms actually don't perform well on them. So we are working towards transfer learning, and hopefully, once we have that, then it's able to generalize in a much better way. All right. Oh yeah, one last question.
So, can the algorithm generalize to different type of documents, like legal documents and scientific documents, where the style of writing has a different jargon that helps you let's say the default scripting?
To a certain extent, yes. Obviously, it still works a lot better on the domain or it was trained on, but as you saw, it does generalize somewhat. Obviously, there is domain-specific language that we'll have to train on, but as far as the reasoning capabilities go, or the reasoning abilities go, those things generalize pretty well. All right, thank you.